Any advice on building companies in the Gen AI era?
I think it's important to pick a problem that you care deeply about. In Gen AI or otherwise, just like building startups is like unbelievably painful. Sam Altman, for example, he's built like one of the greatest startups of all time. And like, he's not out of hot water. Like he still could, it could all implode or, die away or get eaten up by competitors. So it's sort of like this unending series of greater and greater challenges. And I think there's like a pretty fundamental just need to have something that we're really able to anchor in.
So here's a really interesting question. What does routing look like for multimodal models so we're talking image, then video, then I imagine sound, right? And you mentioned this thing about vibe. How I know it's very early days, but what are some hypotheses that you guys have about routing through multimodality?
A vision model that, is perfectly capable at a certain part of the distribution and then fails miserably on another. And then you try a different vision model and it manages to do what that first one didn't, but then it has other weird edge case failure modes. So I think that's something a lot of people have been interested in. It's on our roadmap. Raising is hard, especially your very first round. 99% of startups don't raise any funding. And then 50% of the startups that do raise their first round go on to raise their second round. And there certainly are these fundraising overnight success stories where it just someone's burning on fire and everyone wants to get in on the deal. But
welcome back to the AI Portfolio Podcast. Today we're going to talk about Gen AI model routing with Tomás Hernando Kofman of Not Diamond. Tomás, welcome to the show.
Thanks, Mark. Glad to be here.
So tell us more about what you're building at Not Diamond and also why the name Not Diamond. That's quite interesting as well.
Yeah, let me start with what it is and then I'll tell you about the name. So Not Diamond, it's an AI model router that predictively determines for any query which LLM is best suited to respond. And we outperform individual foundation models on accuracy by up to 25%, while reducing costs and latency anywhere from 2 to 10x, depending on the use case. So the name is a reference to modal logic, which is the logic of possibility. And the diamond operator in modal logic means possible. So not diamond means not possible. And there's this quote by Wittgenstein where he says, "Thereof that which we cannot speak, whereof that which we cannot speak, thereof we must remain silent." So we can't talk about what we can't talk about, which is true. But I think the limits of expression have expanded over time as the technology of language has evolved. And sort of the long-term kind of impulse behind working on this is to help expand those limits into what's not possible today. So that's like the philosophical backstory, but it also just sounds cool, which is the other important reason we called it that.
Absolutely. How long did it take you all to come up with that name? And did somebody just discover it or you had it in queue for a while?
No, I think, maybe a couple of weeks of brainstorming. We had a couple ideas and this one sort of shook out as the winner.
Did ChatGPT help you do it?
I feel like I tried and it ended up being more useful to go deep on just the journal.
Super interesting. So what do you think is the opportunity in the market for routing as a business offering?
Well, we actually started working on this because we had been running into the problem ourselves. My co-founders and I were building something at the application layer. We started running this problem of when to use which model on which part of our application. We saw not only all of our founder friends struggling with this, but also really sophisticated teams, companies like PayPal, Uber, Airbnb, trying to build their own routers internally. And finding that to be a really difficult problem to solve, and also a difficult problem to stay solved over time because every week a new model comes out or an old model gets updated. And so, it's a combination of a difficult engineering challenge plus just a lot of maintenance that doesn't need to get replicated across every team internally. And, maybe 18 months ago, the majority of people were still using kind of one model. And today it's very much not the case. the vast majority of teams and companies are using anywhere between 2 to 6 models from multiple providers, for one simple reason, which is that no model is the best at all tasks. And, we can get really, I think, significant cost and latency savings. The real opportunity is improving quality and accuracy. That's the reason why we see people using more than one model. And I think that problem and opportunity is just going to continue growing as we move into 2025.
So 11 months you've been working on this, I think, officially?
That's right. Yeah. Started at the very end of last year. So yeah, it's been a great first year.
Perfect. So tell us a bit more about the platform that you guys have built or the offering, because it's always good to understand what are the components that different folks may or may not should try to replicate.
Yeah. So essentially, you can think of Not Diamond as a tooling to train or optimize routing to your application. And basically, we can do this by taking any evaluation data over any set of models and any set of inputs and learn a optimal routing algorithm between those models. So for example, let's say you're a financial services firm. You have a workflow where you're extracting certain pieces of data from unstructured text, and you've evaluated a handful of different models, maybe some off-the-shelf models, maybe you fine-tuned a model. And basically what we can learn is for a given input, maybe, analyzing everything from the length of that input, the language, the complexity, the subject, and the piece of data we want to extract, we can learn when to use which of these models. And essentially all of that learning happens automatically through the tooling we provide. Now, we have an out-of-the-box router that is great for prototyping. If you are building a kind of a general purpose application like a chatbot or RAG search over your document base, we can use this out-of-the-box router that has been trained on everything from code generation to text summarization to medicine to law. And essentially the way it's architected is as a recommendation service. So we take the input and the list of models that you want to route between and return a recommendation for which model to use. And that's very fast. Inference speeds range from 10 to 50 milliseconds. And we offer this through our API, but we can also deploy locally to folks' infrastructure. So, on top of that, we offer some out-of-the-box evaluation tooling, though we also integrate with any other evaluation platform or metrics or infrastructure you've built. And also we provide, just a simple SDK interface for switching between different models, falling back if a provider is down. Last week, OpenAI had a pretty big outage, so we can easily fall back and load balance across different providers. But fundamentally, the really important piece that we've built is this ability to tune a routing algorithm to your application.
Can you describe why this problem is hard? Because I think folks might just think of it as a router. Oh, I have 6 models. Okay, that's a 6-class classification problem. How hard can it be? Folks build all this big infrastructure. So can you share some thoughts on that?
Absolutely. So, well, let me zoom out. I think even before we get to 6-class classifiers, the vast majority of teams we see trying to solve this problem are using manual heuristics. And so they start to build these spider webs of if-else conditions. And maybe these are based on semantic clusters. Maybe they're using another LLM to determine which category it should fall into. But, you have your coding problems. Maybe we've seen regex also. Like there's some nasty stuff. And, you start to build this kind of sprawling set of conditions, and then it's very hard to onboard a new model. Or if an old model gets updated, it can break all of these conditional rules that you've defined. Now, this also has the drawback of it's very manual, and the categories that we might define as humans may not actually be the optimal way of slicing up the distribution between the models. Now, there's the other approach that we see is people training classifiers, like you mentioned. And the downside of classifiers, generally where we see people using classifiers, is for routing between strong and weak models, right? So you have like a, a binary classifier, and you're trying to figure out if you can use this smaller, weaker model, or if you can use this larger, more powerful model. And a few of the downsides we see there is there's often, regardless of the size of the cost savings you're achieving, there's some quality degradation. We usually don't see that we're able to improve accuracy until we have three or more models, right? So between just two endpoints, strong and weak, we're having some quality degradation. And also it's very hard to now onboard new models, right? Because we have this frozen classifier. And on top of that, it becomes very hard to adjust that trade-off over time, right? So let's say we train that, we put it into production, and then we see, hey, actually, the quality is worse in production than in our evaluations. And now we want to like move that trade-off higher up on the quality saving side. We have to retrain that classifier from scratch. So it's not very scalable. And so the way that we've approached this is essentially using recommendation system architecture, because fundamentally this is a recommendation problem. And that's not a new kind of problem in ML. And so we we basically learn a mapping from inputs to rankings for models. And using that, we can then predict for a novel input what the ranking should be. And there's a few benefits of this approach. So first of all, by default, we just maximize accuracy or quality. But because now we have a set of rankings, we can begin to use a Pareto optimization to flexibly adjust, in real time or whenever we want, how to make these trade-offs between quality, cost, and latency, because we don't have to retrain the model. Basically, we already have the ranking scores and the cost and the latency scores. So we can do that optimization on the fly. And then the other benefit is it's very easy to onboard new models, because all we need to do is relearn or run evaluations on that model in particular and generate the scores that's fit into the rankings that we've already developed. So this can be parallelized in a highly scalable way that can route to not just two, not just three or four or five, but hundreds or thousands of models if we wanted to scale to that point. So that's the approach we've taken. And I wouldn't say it's like rocket science, in that, again, ML recommender systems have been around for a long time. But it's a thorny, high maintenance problem that, a lot of teams are actually not well equipped to build, or much less maintain.
But the teams that you've interacted with that have tried to build their own thing, what do you think is the estimation of man hours, total time that it took them to build a first sort of V1? And you mentioned this notion of manual heuristics. Is that just something in a JSON config file? What have you seen out in the wild?
Yeah, I mean, so for the teams that have properly kind of tackled this, and we generally see, or the companies, we generally see like a team of anywhere from 2 to 6 kind of tasked with building and maintaining this over time. So it can, easily get very expensive. Now, for the FANGs of the world, that's not really an issue because resources are not the limiter there. But for the vast majority of companies, especially, not only other startups, but a lot of the maybe larger legacy enterprises that don't have unlimited AI and ML engineers, that's a very expensive undertaking. Now, the hacky version of like, if else conditions and heuristics, that's something you can spin up on your own in, maybe a month of time with one engineer building it. But the issue is it's going to be very, very hard to maintain. It's going to require a lot of kind of constant maintenance. We've seen teams who build this, it's running, it's working, and then OpenAI updates a model and now everything breaks and then they just scrap it all, And so it's not a great pattern for folks with, few resources to throw at the problem. Now, obviously, if your app is really, really simple, you know, you may be able to get by with manual heuristics. I generally, as a ML principle, I think starting with heuristics before you build models is, always a great way to start. But for more sophisticated or high volume or high accuracy need applications, we think it makes sense to, have some out of the box tooling so people don't have to roll it themselves.
When it comes to, you mentioned this thing about human categories in terms of someone might try to classify a query as, I don't know, let's say I work in retail, so I work with a lot of retailers. So I might classify something as return, something as complaint, something as et cetera, et cetera. Can you touch a bit more about why these human categories may not be sufficient to drive significant accuracy as we try to switch across models?
Yeah, well, I would suggest that they are as poor a proxy for quality as vibes are a proxy for which model you should use, So
Okay.
basically, there are a lot of people who use vibes, and vibes are not like completely irrelevant. But if you're building a serious application, I think we need to, in the same way that, classical software engineering has very much become test driven. We need AI engineering to be evaluation driven. We need it to be data driven. And so if you just kind of think, hey, this model I think is better than that model, because, you know, it just feels right.
Mm-hmm.
uh, you're going to be moving a lot slower and hitting a lot more snags than if you have some evaluation data that helps you make a principled decision about that. And the same is true about these categories, right? So if you are just kind of saying like, yeah, I think probably should split it up between returns and, complaints and Q&A. What we've seen is that in practice, those categories, in and of themselves do almost nothing for improving the accuracy. What they do offer is they narrow the space so then we can manually tune, the prompting and how we're using a specific model on that smaller distribution. But it's still a pretty rough estimate. Whereas what we've seen is like even on a very narrow, use case like Python coding or a RAG over a large document set, with similar kinds of questions. There are these invisible to the human eye breakdowns in that distribution where different models consistently perform better or worse across that in a way that generalizes, beyond whatever the training data is. So that's generally why I think manual heuristics, and I feel like I've never talked to anyone who, and I'm sure they're out there, but I haven't really talked to anyone who's taken pleasure in crafting all these like heuristics. Like it's a mess, and it's everyone knows that kind of deep down that this is not the way you should be building machine learning applications. But yeah, there's not really a great alternative for a lot of people right now.
That makes sense. Something just popped into my head in terms of, I was coming back to this multi-class classification problem. Okay, given a piece of text, route to another 6 pieces of text. Let's say if we have 6 models. And the thing that stood out to me is how the system prompt. So when the input into, let's just say, an LLM actually has multiple components. So there's a distributional changing factor, which I put myself in a different space to generate text. And then there's the actual text that I go to query. So there is 2 components. And that came out to me when you said vibe, because the system prompt can affect my vibe per se so much. And this particular query might require a vibe. I might want something funny, and that's a whole different typo mechanism, like which model is funnier, etc., etc. Can you maybe give us some insight? You've trained a bunch of these models to do different things across different use cases. How have you seen that difference in system prompt maybe make this problem even more complex? Any thoughts
Yeah.
there?
Yeah, that's a great question. And I'm going to answer it first in the objective sense, where we
Okay.
maybe are doing some like question answering or something that we really know how to measure. And then I'll also talk about what this looks like in the vibe sense, right? Where it's maybe a companion, or it really comes down to subjective and preference. So yeah, certainly the prompt that you use will perform differently across different models. And so if we use the same prompt across different models, just with that, we can already begin to drive performance gains. But what's actually really interesting is when we begin to jointly optimize the prompt and the model. And so one way to think about this is, again, our framework is very general. So when we can route between different models, the term model can be quite expansive. So it can include fine tunes, can include agents, can include the same model with different prompts. Right? So, and actually what we can begin to do is to using, either manual methods or frameworks like DSPy, we can actually algorithmically discover the optimal prompts and then begin routing between them just on the same model. And that already drives pretty significant quality gains. But then when we combine this with the optimal prompts across diverse models, we can get even bigger deltas. And I think this is interesting because prompts actually often have a similar challenge that models do, which is that we need our prompts to be kind of one size fits all, right? So we start finding all these edge cases, we add them into the prompt. It's like, absolutely do not do this thing, and then we find a different edge case. And by the time we get to the end, it starts forgetting some of the things that, were earlier in the system prompt. And so crafting that prompt so that it can cover all of these use cases is pretty challenging. And we can actually optimize just to find, hey, maybe there's one prompt that is going to work better on this part of the distribution and a slightly different prompt that is really on the same task, but it's going to work better on this other part of the distribution. One of my favorite examples of this is using these algorithmic methods. Some researchers discovered that on a math benchmark, I believe the llama models performed significantly better if you started the system prompt with captain's log. And it sort of basically got it into the Star Trek part of the neural network, and it just was better at arithmetic. No one ever would have thought of that, and so definitely, I think that's a pretty important and significant option here. Which again, obviously we can. It's one thing to route between many different models, but when I said we can route between hundreds or thousands of endpoints, this is where the value of this architecture comes into play, because we can really start to generate, thousands of different prompts and ensemble these across the whole data set. I think there's like a pretty big space to explore here. And that brings me back to your other point about vibes, human preference. So, we can basically optimize routing to any reward metric, right? So that can be true or false, or accurate or inaccurate, or, faithfulness on the context that we're generating over. But it can also be, thumbs up or thumbs down. And because recommendation systems are so lightweight, we can even hyper personalize routing to every individual user in the same way that TikTok learns a hyper personalized content routing algorithm for every user. And so we actually have a chat app, has like 50,000 users, and it uses Not Diamond to, recommend the best model for each question you send. But when you thumbs up or you thumbs down, it actually learns your preferences and begins to adapt to those in real time. So I think that's one of the other cool ways that this recommendation system approach gets to move us into a world where we can begin tuning all of these things, the model, the prompt, the temperature, all these knobs that we're kind of manually adjusting, we can begin to do this in a much more algorithmically sophisticated, data-driven, and online way. And that's a big unlock for the industry and for enterprises, because right now it does not matter how many queries you send to GPT-4o. It's always going to be GPT-4o. It's not going to get better the more you send. But with a recommendation system that can learn online, the more volume that we are passing through our application and the more signal we're getting on the outputs of those generations, the better the application can become in this kind of online learning way. So yeah, that's kind of. Does that speak to those questions you had?
You're spitting some game. That's what I have to say. You're spitting some serious games. My brain is on, maybe want to say, high alert. So some of the things that stuck out to me that are sort of shifting a paradigm. So I also work in Rexis, and I think folks will train a single model. That single model will then produce a set of candidates. Candidates could be okay in this case, and then I typically reorder those candidates based on your personal preferences. And now what you are showcasing, one point that I like that you made is that a single model is multiple models depending on the prompt. So now no longer looking at a model as a single, unit that comes, or endpoint that comes from a provider. If we go one click deeper, I can now segment that model based on prompts. So I have multiple models within a single endpoint from a provider. The other one that I thought was quite interesting is how you now will look at model choice optimization across. It's almost like a hierarchical thing in my head. I don't know. Probably you may or may not be solving it like that. A hierarchical, okay, which is the overall endpoint, and within that, what is the prompt structure that I'm going to look at? The captain's log thing is cool. There's an example. The Kaggle Grandmasters of NVIDIA, they competed in the Amazon KDD LLMs for personalization challenge, and they just basically bribed the LLM to perform better, and they got good results. So it's a second thing about, I was wondering if AGI is going to just be bribable or not. That was a thought that came up. But I think one of the most interesting things that you've said so far is that hyper personalization per user comes down to the model, it comes down to the prompt for that person. And then the other thing that just stuck out to me, or maybe we could focus on this one, is the prompts that affect me over time. Like if you look at maybe my engagement with TikTok or Instagram, it'll have some constants, but it'll also shift over time. So there is this notion of prompt drift within each model now. So now I'm really appreciating how complex this problem can be if you want to do it quite right. Wow. Any thoughts on that last one in terms of prompt drift over time?
Yeah. Well, I think that's why, part of what we work on is, not just the offline training of the routing algorithm, but monitoring how our recommendation algorithm across models or prompts is performing over time. So you can set like a sampling rate essentially. So 1% maybe of queries will sample all the candidates and just evaluate, how did our router do? Did we pick the right answer or the optimal answer or not? And that can allow us to see, hey, is the model drifting or the prompt drifting? And then as we're doing that, we're collecting this data that we can use to retrain, and that's where the online learning loop happens.
Mm-hmm.
I do think it's an interesting point, because like if you think about, setting aside, whether what AI is today is actually a good proxy for human intelligence. But if you just think about the way we're interacting, we're picking up all these signals from each other, facial expressions, et cetera, that we might interpret as reward functions. And as we're doing that, the instructions or the system prompt in our head is evolving, right? So it's not like I'm constantly thinking like, hey, I need to say X, Y, and Z, if not diamond, and make sure that, there's maybe some very deep, big meta principles like I want Mark to like me, and I don't want to like hurt anyone or something. But there's a lot below these kinds of larger, maybe guardrail prompts that is kind of constantly evolving in real time. And I think that's like an important feature of human intelligence that is somewhat lacking in the way that AI systems are currently architected.
Hmm. You mentioned guardrails, and I wanted to bring that topic up. So you are a layer in between the final call to a model. Typically, there are input guardrails. You could shut things down there, or you could shut things down coming back. There are different parts of the request pipeline that I can inject guardrails. Where do you sort of envision your platform or your offering sitting in that workflow?
Yeah, so you're exactly right. We sit between the two places where you can put guardrails, right? So you can block a request from the user input side, and then you can also block the generation. And so if the model response comes back with some toxicity over some toxicity threshold, I mean, one of the interesting things we can do is, learn when a particular model is more or less likely to respond toxically and, predictively not send to that model, right? So again, we can optimize for every.
Mm.
Right
Okay.
now, we're really set up to, in terms of these Pareto optimizations, we're really just set up to optimize between a single quality metric, whether that's toxicity, hallucination, accuracy, human preference, whatever you want, and then cost and latency. But we can extend that Pareto front to as many dimensions as we want, right? So now you can, optimize across your accuracy, your toxicity, your cost, and your latency. But we're not there right now. So we really tried to design this to be as interoperable as possible. It sits on top of any orchestration pipelines that you've built, any evaluation frameworks you're using. It basically just sits between, you have the request that a user is submitting or the system is submitting with the messages and the list of candidates that you want to route between. And then Not Diamond returns simply which of those candidates you should send the request to. And then you send that request there. So it basically requires you to change nothing about your existing orchestration architecture.
But within that workflow, my system prompt is already in that request. So I can you help me rationalize between, if you've helped me to optimize my system prompts, that's sort of preloaded on the back end across all different model types? Help me to maybe
Yeah. So if you're
rationalize that in my
using
head.
the same system prompt across all models, then
Okay.
yes. But otherwise, you can pass in the message without the system prompt, and
Hmm.
we'll route to, let's say the three versions of OpenAI with three different system prompts and determine which
Wow.
should be used. Yeah.
I see. So therefore, I should think of you as, to a degree, a system, maybe a system prompt management layer, a optimizable system prompt, quote unquote, manageable layer that I can route, where that is my new definition of a model. A prompted model is a model versus just the big, huge model. Is that
Yeah,
fair?
you can definitely think of it in that way. Again, though, this is very flexible in that we can also route between like a model and an agent, or between multiple different
Mm,
agents, or even between a model and a human being. And so we have
right.
like an example of using Not Diamond to determine when a particular question should go to a human.
Okay.
So really anything that can take, a message input and return
Mm-hmm.
a response that we can assign a score to, we can learn this optimal routing algorithm across it. Now, generally right now, we're mostly working with folks who are, routing between models or between different prompts. We have one use case where folks are routing between different agents. But yeah.
Mm-hmm. Are you seeing also, or how will it work if I have a model? I have multiple LoRa's, so these adapters that know different things. So I would view each adapter as a separate model, and that now becomes my objective, my optimization function for the total models I call. Is that fair?
Exactly. And I actually think
Okay.
this is it's like this pairs very well with any fine tuning technique, because
Mm-hmm.
what we get from fine tuning, especially, if we're using a small model, is we can often, outperform the big generalist models at a lower cost and latency. But what we lose is robustness, generalization. And so if we compare routing with fine tuning, we get all those benefits, but now we can ensemble multiple fine tunes together and ensemble them together with the generalist model as well.
Mm.
And that's actually a pattern we're working with a few folks on as well.
Very interesting. Yeah, even in that competition that I was telling you about, they came up with a scheme for doing a weighted sum of an adapter versus a base model, because they found that the base model could do things that the adapter base model, the adapter combined model couldn't do, and vice versa. So that was their way of sort of mixing. You
Interesting.
meant, yeah, you mentioned this thing, strong versus weak models, and I think that's this. I don't want to say the simplistic. That's the initial distinction that people can make in their minds about one model, big frontier versus small fine tune. Can you talk about what are the extra categories in there? Because I'm thinking strongest, maybe slightly less strong, and there's this almost spectrum in between strong and weak. Can you talk about that?
Yeah, absolutely. And what I would probably push back on is that I wouldn't think of it as a linear spectrum, right? And so
Mm.
actually what we have is you can have multiple strong models that may do better or worse on different parts of the distribution, and multiple weak models. And by having more than just one, if you have just one strong model and one weak model, the quality and cost trade-off sort of linearly degrades, and you can get some alpha there. You can find a middle point right between those two models. But if you have multiple weak and multiple strong, and obviously in between medium models, you can actually get both. You can improve accuracy while lowering costs at the same time.
Hmm.
And so, you could think of it as like maybe this model A, strong model A, does very well on 30% of the distribution. Model B, which is also strong, does very well on 45% of the distribution. And there's some overlap, but not complete. And then you have model C, which is, 100 times cheaper, and that does well on 20% of the distribution. And so now by ensembling all three of these together, we can improve accuracy over either model A or model B while reducing costs at the same time. So that's like, maybe to illustrate this, I think the O1 models and that class of models is actually like a really nice example of this, where we know that they're not actually better than, say, like Claude, Sonnet, or GPT-4 on all tasks. But there are some tasks that it's significantly better on, and it's far, far more expensive. And so even just routing between, say, O1, 4.0 Sonnet, 4.0 Mini, Llama 70 billion, between that kind of ensemble, we can achieve higher performance than any one of those models. And there's a lot in the distribution, again, depending on the task of which a smaller model can handle perfectly well. So that's kind
Hmm.
of, I'd say, the next level up from just going between a strong model like 4 and a weak model like 4 Mini, which, to be fair, is also where we started. So when we started building this, we open sourced a model router that routes just between GPT-4 and GPT 3.5 Turbo at the time, and I think that's a useful pattern. But as we kind of iterated, we discovered that a more flexible approach allows us to do more than just save costs, which is important, but I don't think it's the most important thing right now. I think what we're all needing is like higher quality.
Yes.
So
What you just shared there made me think of you almost as a pruning layer. What I mean by that is I can almost get the best of all the models that I'm exposed to, balanced by some notion of cost preference and maybe total cost preference. So that's quite interesting. And as people think about the cost optimization angle, is it are they optimizing on a per query basis? Are they optimizing total spend per month, total spend per year, per use case? What are you seeing your customers? What's their mind thinking essentially?
I think for everyone, things are moving so fast that it's
Hmm.
not super well systematized. I think generally the big issue is like when the monthly bill starts like, comes back and you're like, oh, like those like, you know, 300,000, token inputs that I sent through like really add up. But I think also I've talked to a lot of larger enterprises that are kind of like thinking back to when everything was moving on the cloud. And, they were basically said, just take your apps and move them onto the cloud. And, they weren't optimized for the cloud. And then suddenly they got hit with these massive bills because they weren't cloud optimized. And there's a sort of hesitation around moving onto AI because people aren't really sure how to forecast the spend, especially if adoption explodes. And for a lot of these large enterprises, it's not trivial to roll something back once you deployed it. And so if adoption explodes and your unit economics are flipped, especially as a public company, you could be in a tricky spot. Now, it's messy and fast moving because generally the industry as a whole is really in an investment stage where what really matters for people is market share. But when cost matters is when it becomes a blocker on quality, when it's like, hey, we are processing billions of requests every day. And if we move this onto the best model, like it's gonna drain our funds like, in a heartbeat. And so that's when people start looking at, oh, maybe I can use this local model. Maybe I can fine tune something. Maybe the smaller model is good enough, maybe not. And that's generally where routing can be a useful pattern for letting for those kind of edge cases where you want the really powerful model, leveraging that while still getting the advantages of the smaller model on the kind of 95% of queries, which may be very simple. What is the customer service phone number or, yeah.
Hmm. How does caching, so saving the outputs of previous prompts and stuff like that, how are you all thinking about inserting yourself into that workflow? And what are you seeing? Today is what? December 17th. Who knows what caching and the future of LLM memories will be? Any thoughts around that?
Yeah, so we, can support and integrate with caching when it's, supported by a provider. And obviously that's your question is distinct from the response caching, which happens client side. But yeah, I think essentially because these are saved within the memory at specific checkpoints, you can specify that in, the routing that you're doing using Not Diamond as well. Now, I think it's an open question for us, like whether you have a certain set of a multi-turn conversation that's saved in the memory of one model, and then you switch to another model halfway through, and how does that balance out? And I don't have like a great answer for that right now. So I'm also interested to see how it evolves. But yeah, I think that's certainly you know caching within a model certainly lends itself towards staying within that model for long, complex, multi-turn conversations. So that's something we're still seeing. We have users who are using us on those kinds of settings, and it hasn't been like a deciding factor to not get the gains they're getting from the routing. But
Makes sense. Yeah, I'd asked a friend who's working on building systems of LLMs, multiple LLMs, and it was interesting to think about how does one LLM remember what I told it versus another one, and how do I transfer that context from one LLM to another? A lot of times, folks reuse the KV cache, so those are tokens that are already processed through that model. So it's interesting. It's as if asking, it's almost as if transferring opinions, but the opinions stay grounded from who they came from. So they always, and it gets modeled. So it's like the communication problem between humans and message passing, and it just gets diluted over time. So yeah, it's complex, quite complex.
Yeah, absolutely.
So how would you advise, let's say, someone to architect a system, or when they're going through this notion of architecting a system where they have some frontier models that are, obviously they have no control over that. They just make the request, they get a response. Then there's their own self-hosted, let's say, in their cloud environment, and maybe self-hosted, sort of on-prem. Any thoughts about optimizing a system like that, or any other considerations as well?
No, honestly, my co-founder would probably have a lot
Okay.
stronger opinions about this than I would, but I wouldn't call myself an expert in model deployment. So yeah, I probably can't share too many nuggets
All
of
good.
gold there. Yeah.
Yeah. Don't give away the trade secrets before you make it big, right? Let's talk about the actual router itself. So what does the process look like to train the router on your platform? Oftentimes, I think people will assume that any really good machine learning model might take a crap ton of data in order to learn a certain space. Tell us about size of data, length of time for retraining, etc.,
Yeah.
etc.
And I'm happy also if you'd like, I can run through a quick screen share
Yeah,
demo. Cool. Let me do that.
I think you'll be the first one on the podcast showing demos. So for those that are listening, we'll see if you can spatially follow in in audio.
Can you see this?
Yeah, Jupyter Notebook, pip install.
Yep. So we'll just install packages here, including Diamond, and we're going to here train a router on this RAG data set, and we're just going to take 200 samples out of this RAG data set, and we're going to train a router on Sonnet, Haiku, GPU 4o, and 4o Mini. And here we're just evaluating or generating the responses from the different models. So you can see basically we have the user question, the retrieved context, the model response, and the ground truth answer, which is provided by the data set. And so then we'll use this just to, again, we integrate with any evaluation tooling, but we have some out of the box on context recall, factual correctness, faithfulness. So we'll evaluate the responses from all models on these metrics. And then here we'll train a custom router on faithfulness, which is specifically, was the model's response faithful to the context, or did it hallucinate something that wasn't there? And so we'll just split into train and eval splits, 80-20. And then basically this is where the routing is happening. So trainer.fit, we just say this is on the training split. So 160 samples. These are our inputs. These are our responses. These are the scores that we've assigned to the responses. And we get back this custom router ID. And then we can evaluate this on the eval split using this ID of that specific router. And here you can see this is, the responses from different models, the scores they've achieved. And you can kind of see that on some of them, like one model, may get score worse than another, and then the opposite happens. And so the best average model here is GPT-4 on the whole data set, scoring 90%. And Diamond is scoring 93.5% here. So effectively reducing the hallucination rate by a third. And what's interesting is you can see the distribution here of responses. A quarter of them are going to Haiku. So between Haiku, Sonnet, and 4o, we're actually reducing our costs by using a smaller model on a quarter of the evaluation split. And so again, here, these first columns are basically, this is the Not Diamond recommended models. So here we're recommending Sonnet. You can see on this specific input, and it's scoring a 1. And then it's recommending GPT-4o, which, is a good recommendation because Sonnet actually scores a 0.5 on that particular prompt. So, I would have no idea, again, manually how to define heuristics to achieve these kinds of generalizable results. And this is essentially the process. So, I mentioned this was done with 160 samples in the train set. Obviously, if you have more, that's even better. And that takes about 3 or 4 minutes. So it's very fast, very efficient. Maybe was that clear?
3 to 4 minutes to train?
What's that?
3 to 4 minutes to train?
Exactly. Yeah.
To basically just, wow. Okay. Very
Yeah.
interesting.
It's very, very fast, very efficient.
So given that it's fast, it's efficient, how often do you recommend enterprises retrain this thing?
So it really depends. Yeah, it really depends on the application and the sampling rate. And usually what we can define a threshold around what the accuracy of the router is in production. And then, you can retrain on a daily basis or a weekly basis. You can obviously have that kind of automatically deploy, so it's learning online, or you can be collecting that production data to retrain offline and, compare on the evaluation results or A/B test. So that depends a lot on the particular customer, the nature of their application. But yeah, daily retraining is very achievable.
Very cool. The other thing that just stuck out to me that I am appreciating more about your platform is what is a model. So we defined a model before. Initially, I could just say it's the original huge model, and then I go down to the prompt level. But now, as you talk about RAG applications, there are a bunch of different embedding models which convert my text into some vector. Then let's go really meta here. Then there is also the re-ranking model, which will fetch those results, re-rank it before it goes to the LLM. And then I think the super in-depth meta is whatever vector database I'm using, that's a bunch of vectors in some high dimensional space. To get those queries very fast, I build a clustering on those vectors. So there's also this other layer of optimization that can happen to drive accuracy. And it seems as if almost if that was explicit, if I chose a model as the base model, the prompt, the ranker, the embedding model, the ranker, and even down to the size of index, I have all of these knobs that I have to tune in order, or I can squeeze really to tune to get the true best performance. So it's very interesting how the space of parameters is slowly exploding.
Yeah, I think it is, in a way, it's kind of like a hyperparameter optimization search problem. And right now we're focused on the parts of that funnel that are kind of like highest delta, but we actually do have, specifically for retrieval parameters, we have some tooling in our SDK as well that can kind of hyperparameter optimize those for you based on the specific, document store that you're searching over. But then, yeah, when you take into account the embedding model and the clustering algorithm over the particular vector database, there's a lot that can be done there. So it's a very, very big space, which I think is exciting. But yeah, we're definitely still very much at the beginning of that journey.
Can you just recap about how a new model is onboarded? Right.
Mm-hmm.
So if it's 3 to 4 minutes, I guess we just retrain in that case to get that model inside. Is that how it'll work?
So yes, you can do that. The way we've architected this is basically you can just submit the evaluation data just for that model, and it will add it into the ranking. So again, we actually do this in a parallel, sort of like independent way, so that the evaluation data of model n+1 doesn't affect the rankings of all the other models. So that makes it very efficient and scalable.
Wow, that was a good design decision, because often my mind is thinking back from a Rex's perspective. For instance, a lot of folks have matrix factorization in production. Matrix factorization will only work on items that have been seen or interacted with. So if there's a portion of products that were never interacted with, they don't get included. And in order to get those in, I need to essentially retrain the entire model. So it's cool that you have this. So you essentially have an incremental update, if I could position it like that.
It's very easy to onboard or offboard models.
And offboard, I guess, follows the same paradigm as well, since it's an independent
Exactly.
mechanism. All right. Talk to us about how each of these models, they have their own different pricing, updating randomly every day. Are you doing that fetching of pricing for me, or do I have to sort of, make those calls out? And is that on a per query basis? I'm monitoring live. GPT dropped today. Just okay, choose that one. How is that working?
So we do kind of update this in our out of the box router, but then in the, for folks who are training their own custom routers, you can define all of this, because also, you may have an enterprise contract that changes your, the cost or
True.
the latency over what you might get through the public endpoint. So we let people define this themselves. And right now, the way we do the Pareto optimization is using the cost per tokens rather than the cost per response. Now, there may be some loss there in that, like, maybe there's a cheaper model, but it's more verbose. But generally, like, the divergences in costs are so big that doesn't really, make a significant difference. But yeah, you can do that on a per query basis, even like for latency, for example. Um,
Mm-hmm.
you can report the latency of every single model, update it after every single response.
So folks that are very latency sensitive can essentially optimize for that as well, right? Over time.
Exactly. Yeah. And generally, I mean, so if for very latency sensitive applications, we generally recommend, deploying locally to avoid the whole network latency of calling our API. So again, the actual router inference latency will range from 10 to 50 milliseconds. So, if you're able to drop to a much faster model, shave 500 milliseconds off, then that the 10 to 50 milliseconds is pretty unnoticeable. And then, yeah, we can also keep updating that in real time as the latencies of the endpoints maybe fluctuate, especially if you're using like a public endpoint from OpenAI directly, where the latencies can fluctuate with traffic and time of day.
Can you talk about the limit? Well, I don't want to say the limit, but the upper bound of latency when it comes to the size of the prompt coming in and how that affects your corresponding latency? Because if you're using, for instance, a traditional LLM based thing, you do your own attention and you'll make that decision as well. So any thoughts around how the size of prompt affects latency of your specific model?
So right now, the way we do this is we compress very long prompts to something around, a few thousand tokens that samples from the beginning and end, but also from some from the middle, but mostly from the beginning and end. And that's, sufficient to achieve the quality improvements that we're achieving. But yeah, I think there's a lot of different ways you can approach that.
Yep. Yeah, because you're just branching at the end of the day. You don't need the true
Yeah,
full
yeah,
fidelity, essentially.
exactly.
What Who's the ideal customer for your platform?
So we went to market actually with a more bottoms up approach, building for developers. Because we're developers, we face this problem ourselves, and then we're really surprised after launching just how many large enterprises were reaching out to us. Fortune 50, Fortune 500 companies, and actually in the last few months, that's where we've been really focusing and starting to partner with folks specifically who are leveraging very, very large volumes of data that are very latency sensitive. We often see RAG as kind of a primary pattern here, where we're working with folks. Financial data and very high data volumes are also kind of patterns that we see. I think data processing, metadata labeling, it's an interesting use case because we're often dealing with like billions of cells of information that we need to process, and that's a case where cost and latency do start to become a concern. Whereas maybe for a customer support chatbot, that is much less of a concern. And also accuracy becomes very, very important in these sort of high data volume workflows. But generally, where we see folks getting value from this is either they're already post production and they want to further improve their accuracy and manage costs, or they're building something that is very, very, needs to reach a very high accuracy threshold and efficiency in order to reach production. So yeah, that's generally the folks we're working with, but it's still, we're an early stage startup, so in flight.
In flight. Oh, that's actually a great segue into so in-flight batching is when I have a bunch of requests coming in, and let's say you're on the GPU says, okay, that request is finished. I can stick another request in there versus just waiting for all requests to complete. So what are you seeing, or how do you perform on high traffic online inference? So a bunch of people just hitting my system versus large offline batch. So every night I want to run through all of these documents and but optimize for accuracy and cost. Is anything different in the performance or consideration of the platform?
Yeah, no, we can, run for offline, batch inference as easily as for online, right? So we can generate all of those recommendations ahead of time and then, batch them out to the various providers who offer batch inference as a service.
Ooh, that's clean, man. Ooh, this is getting quite cool. Um, you mentioned that I could do this for agents. So can you double click into that? What should we be thinking about routing across agents? Because now there's how that agent interprets, then it's that corresponding tool performance, and now we get even one level deeper.
Mm-hmm. So there's two senses. Essentially we can route to agents and we can also route within agents. And so if you think of an example of routing to agents, we might have multiple RAG agents. So instead of trying to fit our entire document store, maybe across tens of thousands of documents into a single RAG agent, we might be able to split that up into various, sub RAG agents. And then we want a way to determine based on the input, hey, which of these RAG agents should respond? Because then if we can essentially shard the RAG, document store, we can achieve significant latency improvements by kind of knowing when to check on in which substore. So that's an example of routing between agents. But then within agents also, and this is actually something we're still exploring. We're working closely with one of the kind of leading AI coding agent teams. So I haven't announced anything, but should have some exciting things coming up soon. But basically, agents, it's a very interesting opportunity for routing because unlike, say, a pure wrapper where we can kind of really manually exert ourselves around tuning the prompt and the model, we're seeing unseen inputs across unseen tasks. And so this is an example where we can really get significant gains by having learned across the system when a particular model or model prompt combination is going to be best served for a particular unseen input into the agentic flow. There's a lot more to investigate there, but I think it's a very exciting area that we're excited to share some more about soon.
And have you seen any interesting innovations when it comes to, I don't want to say prompt compression, I'll call it prompt pasting. So what I mean is sometimes hey, reorganize this data, and it has to go through it, it'll get interpreted and then almost stream out as tokens versus just saying, take this chunk, put the chunk, take that chunk, put the chunk. Just as how we would maybe organize in blocks versus tokens. So have you come across anything with teams that you've interacted with about efficiently doing that type of prompt request, this copy paste kind of vibe?
And just to make sure I understand, are you sort of talking about a situation where you have a complex prompt and then you want to split it up into subprompts, or are you talking about something different?
Something like that, but this is more of a theoretical meta question. So technically, the LLMs will stream. They have to re-output every token in sequence. So
Mm-hmm.
to some degree, they're bound to do it on a per token level. But
Mm-hmm.
the task of re-ranking in an LLM essentially is re-ranking. Let's say if I was re-ranking sentences, that's almost on a token level. So now I have to go re-rank all of the tokens specifically and keep coherence of the sentence. And you're just using up more and more tokens versus just saying, hey, I don't want you to do anything with the ordering of this token, just like order these lines, order these sentences instead of ordering these groups of tokens. Does that make sense from a simple example perspective?
I think so. So you're almost saying like instead of like generating over the space of tokens, like generating over the space of sentences.
Yes. And that this thought is coming out because you have this capability, or you're giving me this capability to route very effectively. And I could say, okay, this is actually just a reordering task. So take these chunks and just shift the order of them and give them back to me with some extra text. You see what I'm saying?
Yeah, I hadn't really thought of it in that way. I mean that does, the size of that space definitely begins to get far beyond, hundreds or thousands, into, trillions of combinations of chunks. But I think if, you know, I definitely think that if you can, depending on the specific problem, if you have like a limited set of chunks that you just need to rearrange like in a very structured setting, then there may be a way of I mean, essentially one of the things we can route to is like also deterministic functions, right? And so if you can just think about like the combinatorial, set of candidates from a certain set of chunks, we could like, yeah. I don't know if I'm actually understanding correctly though, or if I'm speaking the way.
Yeah.
I feel like your idea is more nuanced than what I'm picturing.
Well, I'm just coming from it from two perspectives: one, latency, and two, cost.
Mm-hmm.
So if I pass in 10 sentences and I say, this is just us just having a chat on this, right? If I pass in 10 sentences and I say, reorder these sentences based on whatever preference I'm giving you, I could essentially almost like hash each of those sentences, and then just, that's now one token, and it just gets pushed back on the UI. I just retrieve the sentence, right? So
Mm-hmm.
it makes me think a lot about your role in this optimization of cost. Is that sort of this token optimization. How can I optimize on a token, a group of token levels? So I'm just giving you extra requirements for future things to build.
Yeah. I mean, I think because at the token level, this becomes a mixture of experts problem, which is in fact, what most of the frontier models are nowadays, right? So it's basically and that's in a more frozen end to end way, but we have a router or ranker that determines which of the sub experts to use to generate the next token. Now, in terms of like routing between a set of fixed potential, like, if there's a way either in a generative architecture to expand to like, larger chunks of tokens, I think like that's a very interesting question. And generally I think like one of the areas I'd been spending time in before going in this direction was just thinking about tokenization, which, feels like there's a lot that can still be done there. And I think like, just Chinese has a much higher information density per token, say, than English, for example.
Mm-hmm,
And
mm-hmm.
so, what's the limit of that? And so and that starts to get into like more prompt compression, right? Like so, kind of getting very very high information per token density, but then thinking about like, yeah, what is like a bigger chunk than just like the kind of tokens that we have in our current tokenization techniques like TikTok token or whatever. But yeah, there's a lot of, I think, interesting work to be done there.
Yes, indeed. So here's a really interesting question. What does routing look like for multimodal models? So we're talking image, then video, then I imagine sound, right? And you mentioned this thing about vibe, how I know it's very early days, but what are some hypotheses that you guys have about routing through multimodality?
Yeah. So let me start with the simpler case, which is text to X. And that's actually, we can already do that. So we can already, you can use Not Diamond to route between different image generation models, for example, or video generation models, as long as all we need is the input here for the output, we can basically put a null for the output, and then the scores for the different responses. So we actually have in our chatbot the ability to generate images, and we're collecting human preference data over different image generation models. So that's the simpler case. Now, vision also, that requires like a very different architecture. It's on our roadmap, but it's something we get asked about a lot because similarly, you know, you'll have like a vision model that is perfectly capable at a certain part of the distribution and then fails miserably on another. And then you try a different vision model and it manages to do what that first one didn't, but then it has other weird edge case failure modes. So I think that's something a lot of people have been interested in. It's on our roadmap, and then there's things like real time video, like if you're like vision in terms of like a real time video, and that I think is like obviously it's another level of complexity. It's an extension of the vision problem, just because like it depends on how frequently we're taking these snapshots of the video feed, but we haven't even gotten there yet. And then if you're combining all of these, right, in like image generation and video and voice, and then that is our current product would not work on that for sure.
But it's good that based on that, there's so much runway that you have in terms of problems to solve. And just because of that complexity, traditional enterprises would definitely be wasting their money trying to do that in addition to all the other things that they're responsible for. So I wanted to talk to you about building startups. You're currently building one, you're a co-founder. And so tell us about the story behind meeting with your co-founder to do Not Diamond and deciding to take the plunge to go do it.
Yeah. So, well, I had stepped back from my last startup in early 2022. I worked on that for 4 years through 3 rounds of funding. And early 2022, I'd been going really deep on AI. My last startup was not in AI. And I'd been seeing people building more powerful models and working on the interfaces between these models and humans, but not very much work being done on the interfaces between the models themselves. And that felt like a big gap in the ecosystem, both for performance and also for safety. And so I kind of just started diving in. I was, getting my hands dirty with the code, like reading hundreds of papers. And that's how I actually met one of my co-founders. I read his paper and reached out. He did his PhD on networking together diverse models to outperform monolithic models as task complexity increases. And then he co-founded a startup with his grad supervisor using the optimization techniques in his research, specifically on video streaming as a problem. And then after that, joined Bell Labs as a machine learning researcher. And my other co-founder, I've known for a long time through friends. He did his master's in machine learning and data science at Columbia, and then has built his career in data-driven growth, sort of from day zero up to tens of millions in revenue. And he's also was a researcher at UC Davis doing graph network research.
Okay, it's a
And
strong
so
team.
I feel very, very lucky to work with my team. Everyone else we work with also, it's just incredible people. People have turned down OpenAI and Anthropic and X, and like I'm very blessed. Some pretty amazing folks. So, but we had this thesis about building infrastructure for networking together different models, and this actually goes back to the name, where we were, if you think about humans, our brains haven't changed in 100,000 years. Um, but what has changed is the technology of language and how we network with each other to share and store and do work on information. And that has led to this explosive growth in our intelligence and our capacity to create value. And generally, on a wide enough, input space, the universe tends towards distributed systems as opposed to monoliths. And so we started building, we had this thesis that the same would be true for machine intelligence, that there would not be a one size fits all model that everyone uses for everything. And actually, that if we could build infrastructure that helps us shift towards a future of leveraging, networks of specialized smaller inference systems, that would not only be more effective and more computationally efficient, but also a safer world to live in, moves us away from monopoly dynamics. So that was like our thesis. And then, as I said, we kind of iterated on a few different things. We were thinking about vehicle to vehicle communication and self-driving. I actually think there's a lot to be done there, but it's not a great place to build a startup. Highly regulated, very few buyers and players. And then we were building something that was more at the application layer, and we started running into this problem. And then, actually we were running into this problem, but also with what we were building, we weren't seeing a lot of pull from the market. It was like a no code app that helped you combine together different models into workflows, sort of for you can think of it sort of like Langflow, or there's a lot of these apps now. And we weren't seeing a ton of pull. And then I think also I hit a point where I realized, like, what's the worst that will happen if we don't build this? Like, someone else will build it. Okay. And what if no one builds it? Well, that's fine, actually. Like, the world is going to be okay if you can't more easily connect, like, your Dolly model to your Llama model to your Asana. Like, it's going to be fine. And So that's when we kind of went back to the drawing board, and we saw, amongst the different things we were thinking about, we were looking at this problem we had been facing. And that's when I kind of like pinged some friends about it. I was like, hey, like, is this something you're struggling with? Or, and immediately there was like this big, response. And we started reaching out to people at these large companies. And as I said, heard they were trying to build this themselves and finding that to be challenging. So we saw a very different response. And I think one of our takeaways was like, it's important to work on, I think that previous idea was something that even if it had been successful, it wouldn't have felt, meaningful, maybe that particular way of building around this thesis. And so we wanted to choose a problem that would feel meaningful, even if it failed, even in the face of failure. And I actually think that's a very valuable thing in building a startup, because like you're going to be staring failure in the face like every day, every week. It's just like statistically, the most likely outcome. So yeah, that's kind of how we got to where we are now.
Very exciting. Very exciting. And what advice do you have about raising funding? Have you guys raised? What have you can share in that realm?
Yeah, so we're lucky to have some amazing folks: Jeff Dean from Google, Julian Chamon from
Wow.
Jan Stoic from Databricks, and Anyscale, many other, heroes of ours, former OpenAI executives. And I think raising is hard, especially your very first round. I think 99% of startups don't raise any funding. And then 50% of the startups that do raise their first round go on to raise their second round, and by round, I mean like a proper round with like an institutional lead, et cetera. So that first round especially is very, very difficult. And I think, there certainly are these fundraising overnight success stories where it just like all just, someone's burning on fire and everyone wants to get in on the deal. But actually the vast majority of fundraisers are just later told that way, right? So and there is a point where once you get like the momentum, then everyone wants to pile in, right? So we were massively oversubscribed, but there was a lot of sweat going into, when we actually got that first, our lead investor in the round. And, a lot of rejection, a lot of getting very close, and then, the deal falling through. And so it's very demoralizing. And you basically have to spend like a couple months of just going to talk to some of the smartest people in the world so that they can tell you why they don't want to spend their time with you. So you kind of need to like just be like willing to like get up and punch in the face and then just keep going. And but I also think, tactically, what we did was we put together a list of everyone we wanted to get to invest, and then we just went after them by hook or by crook. So one of my favorite ways of doing this is I'll reach out to the portfolio companies of the investors who I want to work with and just say, hey, I'm a huge fan. Like, I'd love to get your advice. And, this is, months before we actually start fundraising, and just actually get their input on what we're building, which also is an incredible education because these founders are just, they'll bring so many perspectives that I never had considered. And then later, they'll ask like, how can I be helpful? And I can say, hey, I noticed X, Y, and Z invested. Like, would you be up for making an intro? In some cases, I cold emailed people, and that worked. I don't want to name names because I don't want people's inboxes to get
Go, email it.
but yeah, just like being systematic and not willing to give up. And yeah.
Strong story, man. Any advice on building companies in the Gen AI era? So we're in a new phase, and what is your moat? Why can't someone come on? You have this fast model. Why can't someone just go do this themselves? What principles are you all using to build this company in the Gen AI era?
Yeah. Well, the first goes back to what I mentioned. I think it's important to pick a problem that you care deeply about, because in Gen AI or otherwise, just like building startups is like unbelievably painful. And like, I don't know, I sometimes like Sam Altman, for example, like, he's built like one of the greatest startups of all time. And like, he's not out of hot water. Like, he still could, it could all implode or, die away or get eaten up by competitors. So it's sort of like this unending series of greater and greater challenges. And so I think there's like a pretty fundamental just need to have something that you're really able to anchor in terms of a North Star that leads you through all of that. Now, specifically in AI, I think there's a few things that we used while we were approaching this. So one is we were actually looking at the way at the time we started building this, everyone was trying to create a foundation model company, to build like this one size fits all model that if you can win that market, you're basically going to build the biggest company in the world because you'll build AGI. And I think we had this theory that building models actually doesn't really have any network effects. There's no, there's a research driven and technical mode, but if OpenAI just kind of paused operations and just went on to maintenance mode for like 1 year, they would go out of business. And whereas like if you take a company like X, you could literally change the name and light it on fire and fire like 80% of the staff and everyone still uses it. You can't get off it. Like there's been so many competitors because it has incredibly powerful data-driven network effects. So that was one question we asked ourselves, like, how can we build something that the bigger it gets, the more it's used, the more difficult it is to get off of it. And so that's kind of what led us towards this recommendation system approach towards networking together different models. The other thing I think that is not the way we're building this, but generally I think the other pattern that is not really anything new, but executing in a vertical with like a very, very strong product sense, I think is also a great way to build an AI company. If there's a particular problem space that is in particular loaded down by bureaucratic processes or lots of manual, kind of low level but non-automatable review. That I think, I'm seeing really fantastic companies being built specifically on solving these very narrow problems that right now don't have great non-human solutions. And then the third thing, I think, a maybe the next step of that, which is, I think there's this like, some people I talk to maybe say like, eventually there's going to be kind of a limit, like it's going to be human level. And then we're not going to really need all of this kind of these improvements. Like the cost is going to go to zero. Like it's basically going to do everything we think or need it, we'd want it to do. And actually, I think there's a whole sea or ocean of things that we've never even considered possible. And so, there's like customer service, like we kind of know what the limit on customer service is and we'll automate that, right? But things like code generation or medicine or data processing, like these are things that we could be doing so much more of this. We're nowhere near the limit. And, if AI, there's this like Jevons paradox where like the cheaper a staple good becomes, the more we actually spend on it collectively as a society. So, if you think about, well, what happens if the models get 10 times more powerful and a million times cheaper? Well, what are all these new things that get unlocked? Can we suddenly have evaluation on every single surface area of every single software process and system in the world? Can we start to bring this to physical spaces as well, where we can begin to kind of monitor and collect data and do operations autonomously on that data on all kinds of physical systems? And yeah, so I think there's like, that's the more like giga brain or universe brain way of thinking about
Mm-hmm.
this. Like, what are the kinds of problems that we could never have solved before, instead of how do we solve the existing problems better?
Absolutely. Beautiful outlook, by the way. I really appreciate you sharing that. So as we sort of wind down, I'd like to really get to understand you as a person. So here's my question. What is your career optimization function? Is it wealth? Is it free time? Is it happiness? Suffering? What is it for you?
Yeah. So for me, I think it's impact. I feel like
Okay.
there are a lot of reasons to work on a startup, but I think generally it's not a great way of making money. Some people get very lucky, but
Mm-hmm.
statistically, it's just like way worse than like taking a job at Google or something. And happiness, yeah, it's a pretty tough road.
Mm-hmm.
And you certainly learn a lot, but you also feel like an idiot like way more of the time. And then I also think like I see people getting into startups because like the sense of you get to be your own boss, and I really can understand if you're working at a large company and you're kind of constantly, doing following directions from others, that is not a fun way to operate. But I also think that actually when you're building a startup, like you're very much not your own boss. Like the customers are your boss, the market is your boss, your team, there's so many other stakeholders that now you're beholden to and responsible for. But I think that if you tune it correctly, and this is not always the case, but if you do, then startups can be one of the greatest engines for long-term sustainable impact at scale.
I
Markets
see.
are not well positioned to solve all problems. I mean, we're still getting there, but like global warming, it's, you know, you need some kind of non-market forces. Maybe addiction is also an example of like markets are not great at solving addiction. They actually, regulation can be helpful there. But if you can point a market at a problem, there's almost nothing that's more powerful for driving change. And I think Tesla is like a very simple and amazing example of this, where it's like, no, we're not, regulating and forcing people to electrify their vehicles. We're building like this sexy sports car that taps into people's vanity and is way faster and has better handling than the gas engine cars. and now everyone needs to follow suit. So that's an example, I think, of that, and that's generally my optimization function. Yeah.
Exciting, exciting. What's one piece of advice you have for a high schooler, someone in college, and a professional? They could be the same, but just in general, what's your outlook?
Mhm. So probably main piece of advice, if I think back to myself, is the importance of mental and emotional health. And in the past, optimized for a lot of other things, like how many hours I worked, what my grades were, the kinds of university I got accepted to, et cetera. And especially all of that maybe underlies like, what did people think of me? Did people like me? And actually, I think that much more than, certainly in terms of like how to drive impact in your career, much more than the hours I work, I think the most important work I do as a leader is build good relationships with people and make good decisions. And both of those are the first thing to go when I stop taking care of myself, when I start acting reactively from anxiety or fear or exhaustion. But I also just think like it's very, that what I was talking about in terms of knowing what a problem that matters to me looks like, it's very hard to do that when I don't actually know who I am. And, frankly, I think like a lot of my life growing up, I really had no idea who I was. And if I saw a glimpse of that, I was very scared of that because there were all kinds of weaknesses and fears and all these things that didn't appear in the characters in movies or on social media or whatever. And so I think that is certainly not a overnight process, but I think prioritizing that introspection and prioritization of mental and emotional health wherever that may lead, which is often can be a frightening and uncertain path, has been helpful for me much more than any kind of like book I read or a skill I learned or strategy I applied to my career.
Beautiful, beautiful. Last rapid round of 3 questions. So, what's one thing that brings you joy besides startups?
My sister just got a puppy.
Ooh, yeah,
uh,
those things.
that's the first thing that comes to mind.
Very cool. So you're stuck on an island with a specialized chef. The chef could cook anything. They can fly in any ingredients. You're going to be stuck on this island for the next 10 years building not diamond. What 2 meals would you have that specialized chef make?
Uh, I would have them make protein shake and bell salad. No, it's horrible, but yeah.
Simple, simple. Yeah, healthy man, healthy man. Okay. Last one. If you had $1 billion, what would you do with it?
I would probably invest it in other engines of driving impact, whether in the startup or nonprofit space. So yeah.
Great, great. Tomas, it was an absolute pleasure in this conversation. I learned a lot, and I'm really excited to see what you guys are building, and best of luck. And we'll be keeping an eye on you as you
Yeah.
hyper
Thank
growth.
you, Mark. Yeah, super thoughtful questions. Really enjoyed our conversation. Enjoyed getting to know each other, and thanks for having me on.
All right, we'll be in touch. See ya.
See you.